Hello and welcome to the class on test of significance, the Z-test. Z-test is a statistical procedure which is conducted to test the significance of the difference between a statistic and the parameter, or between any two statistics, or between the two proportions. Z-test is applicable when the population follows normal distribution, when the sample size is more than 30, sample is drawn at random, and population standard deviation is known. The Z-test is conducted to test the significance of difference between the sample mean and the population mean, where the first step is to put forth the null hypothesis that there is no significant difference between the sample mean and the population mean. Second step is to calculate the value of z, which is obtained by the given formula. Z is equal to sample mean minus population mean divided by standard error. The calculated value of z, known as z-score, is the distance from the sample mean to the population mean in units of the standard error. Now, if we know the population standard deviation, the formula takes the shape of x bar minus mu divided by standard deviation divided by under root capital N. And if the population standard deviation is not known and the sample size is quite large, then we can use the sample standard deviation as shown over here, where x bar denotes mean of the sample, mu is the mean of the population, sigma denotes standard deviation of the population, capital N denotes size of the population, SD denotes standard deviation of the sample, and small n denotes size of the sample. The conclusion will be based on the comparison of calculated z value with the table z value as shown over here. If the calculated z value is less than table z value, that is 1.96 at 5% level of significance, we say that the difference between the sample mean and population mean is non-significant, and therefore null hypothesis is failed to be rejected. If calculated z value is greater than 1.96, then we say that difference between the sample mean and population mean is significant. Null hypothesis is therefore rejected. Whereas if the calculated z value even exceeds the table z value at 1% level of significance, that is 2.58, we say that the difference between the sample mean and population mean is highly significant. Null hypothesis is again rejected. The Z-test is also conducted to test the significance of difference between two sample means which are taken from two different populations, where the first step is to put forth the null hypothesis that there is no significant difference between the two sample means. Second step is to calculate the value of z by the given formula. If population standard deviation is known, we can use it in the given formula, else we can use the sample standard deviation in the given formula as shown over here. The decision will again be based on comparison of calculated z value with table z value, where calculated z value, if it is low than the table z value at 5% level of significance, null hypothesis will be failed to be rejected. If it exceeds the table z value at 5% level of significance, then we say that the difference between the two sample means is significant. And if the calculated z value even exceeds the table z value at 1% level of significance, we say that the difference between two sample means is highly significant. Z-test is also conducted to test the significance of difference between the sample means which are taken from the same population. Here, the formula takes the shape of x1 bar minus x2 bar divided by standard deviation divided by under root capital N. Here also we can use population standard deviation if it is known, or else we can use the sample standard deviation as shown in the given formula. The decision again will be based on comparison of the calculated z value with the table z value as shown over in this slide. Z-test is even conducted to test the significance of difference between two proportions. Now, the sample proportion and population proportion can be compared with the formula sample proportion minus population proportion divided by standard error of the proportions. Or, to test the significance of difference between two proportions of the same population, we can use the formula observed difference minus population difference divided by standard error of the difference between proportions. Thank you.